Assalamu alaikum students. Hopefully you are enjoying learning through online classes. I welcome you all in your second online Google Classroom. Student, in this presentation you are going to learn the most important topic of this chapter, that is logarithm. This is also the name of this chapter. And also you will learn how to convert exponential equation in logarithmic equation and logarithmic equation into exponential equation. And their application we will discuss in exercise 3.2. First of all, I'll explain the definition of logarithm. The standard form of writing logarithm is y is equal to log x with base a. That is, y is called the logarithm of x to the base a. If we convert this logarithmic equation in exponential equation, we will write it as x is equal to a raised to the power y. Now student, I will explain the standard form of logarithm through the example. The example written in the bottom is log x is equal to 2 with the base 3. If we convert this logarithmic equation in exponential equation, we will write it in the form 3 raised to the power 2 is equal to x. So the answer of x will be 9. Through this simple example, student, we observe that what is the function of the logarithm? Through logarithm, it will help us to find out the exponent of any number. This is very simple example, but in some cases it is difficult for us to find out the exponent of any number. So in these conditions, logarithmic equation help us to find out the exponent of the number. This example will help us in understanding the concept of conversion of logarithmic equation into exponential equation. As you can see in the example, there is 2 raised to the power 3 is equal to 8. If we convert this exponential equation in logarithmic equation, first of all we will write log, log, 2 base as it is, and we will interchange 3 and 8 with each other. Same process we will apply if we convert logarithmic equation into exponential equation. We will write 2 as it is and interchange 3 and 8 with each other. Question number 4. What replacement for the unknown in each of the following will make the statement true? I am going to explain the second part of question number 4, that is log with base a 6 is equal to 0.5. First of all, we will convert it into exponential equation. For this, we will write a in base, 0.5 in exponent, that will be equal to 6. Okay, student, you know that 0.5 is equal to 1 over 2. So, in the next step, I will write a raised to the power 1 over 2 is equal to 6. Now, taking square on both sides, you know that square and 1 over 2 cancel each other. So, in left hand side, there only remaining a, and the 6 square will be equal to 36. So, your answer of a is 36. Student, now I am going to explain first part of question number 5. That is log base 2 1 over 128. First of all, we will suppose this number is equal to x. In the next step, we will convert this logarithmic equation in exponential form. So for converting this logarithmic equation in exponential form, we will write 2 in base, x in exponent, that will be equal to 1 over 128. After it, we will calculate the prime factorization of 128. Prime factorization of 128 is 2 raised to the power 7. Student, you know the property of exponent. If we shift denominator term into numerator, the exponent sign will be changed. So in the next step, I am going to shift 2 raised to the power 7 in numerator place. so their exponent sign will change. So 7 change into -7. Student, now you are going to learn one more property of maths, that is, if the base of numbers are same in left hand side and right hand side, then we suppose their exponent are also same. As you can see, there is 2 raised to the power x in the left hand side and 2 raised to the power -7 in right hand side, and their bases are same in both sides, left hand and right hand side. So we suppose that their exponent are also same. So through this we can derive it, x is equal to -7, and that is your answer. In question number 6, we have to find out the value of x. In its first part, the question is log x with base 2 is equal to 5. So first of all, we will convert it into exponential equation. It will become 2 raised to the power 5 is equal to x by interchanging x and 5. Student, you know that 2 raised to the power 5 mean 32 by multiplying 2 5 times. So in first part, the question is so simply solved and we get the answer x is equal to 32. But in next part, question is log 9 with base 81 is equal to x. Again converting it by in exponential equation, we get 81 raised to the power x is equal to 9. Student, in this question you observe that the variable occur in its exponent. So in these type of equation we follow a rule. In this rule we will make base same. If variable occur in exponent, we will make base same. In right hand side there is 9. So in left hand side we will also convert the number with base 9. And you know that 81 is a square of 9. So we will change 81 into 9 square. In the next step, our equation become 9 raised to the power 2x is equal to 9 to get base same. So according to rule, if the bases are same, so their variable will be same. This implies that 2x is equal to 1 because bases are same, so they will cancel out each other. So in the last step we will get the answer, that is x is equal to 1 over 2 by shifting 2 from left hand side to right hand side. Same procedure we will follow in part third. The procedure is, if variable occur in exponent, we will make their bases same. Okay, in the last part, fourth part, again the question is log 64 with base x is equal to 2. We will first of all convert it into exponential equation. X square is equal to 64. So we know that 64 is 8 square. Now just taking square on both sides, we will get the answer x is equal to 8.